Subscribe and download over 1 million code snippet including this tutorial from codegive.com, link in the description below. Multiprocessing is a Python module that allows concurrent execution of code using multiple processes. This can be particularly useful when you want to parallelize a task, such as iterating through a loop, to improve performance. In this tutorial, we'll explore how to use the multiprocessing module to parallelize a for loop in Python. Before we begin, make sure you have Python installed on your system. You can download it from python.org. The multiprocessing module in Python provides a process class to create and manage individual processes. Each process runs in its own Python interpreter and memory space, allowing for true parallelism. Let's consider a simple example where we want to calculate the square of each number in a list using a for loop. We'll parallelize this task using the multiprocessing module. In this example, we define a function square_numbers that calculates the square of each number in a sublist of the input list. We use the multiprocessing.Manager to create a shared list, result, between processes. We then divide the list of numbers into chunks, and each process is responsible for a subset of the input list. Finally, we start the processes, wait for them to finish using join, and print the squared list. Save the above code in a file, example multiprocessing_example.py, and run it using the command. You should see the original list and the corresponding squared list printed to the console. Multiprocessing in Python provides a convenient way to parallelize tasks and improve performance. In this tutorial, we demonstrated how to use the multiprocessing module to parallelize a simple for loop. You can apply similar principles to more complex tasks to leverage the full power of multiprocessing in Python. ChatGPT. In this tutorial, we will explore how to utilize the multiprocessing module in Python to parallelize a for loop, thus improving the performance of your code by leveraging multiple CPU cores. Multiprocessing allows you to run multiple processes concurrently, each in its own Python interpreter, which can lead to significant speed ups for CPU-bound tasks. Make sure you have Python installed on your machine. You can download the latest version from Python's official website. Suppose you have a computationally intensive task inside a for loop that takes a significant amount of time to execute. The goal is to parallelize this for loop using the multiprocessing module to distribute the workload across multiple processes and reduce the overall execution time. Here's a step-by-step guide to achieving parallelization using the multiprocessing module. Create a function that represents the work to be done inside the loop. This function will take an argument and perform the computation. Use the pool class from the multiprocessing module to create a pool of worker processes. The number of processes should be chosen based on the number of available CPU cores. The pool.map method distributes the workload across the processes and returns a list of results. You can now process these results as needed. Save the script and run it using the command. Here's the complete code. This example demonstrates how to parallelize a simple computation using the multiprocessing module in Python. Adjust the number of processes based on your system's capabilities, and adapt the process_data function to suit your specific compu. ChatGPT.